Hi, everybody. So today I'm going to talk about WorkManager. And my goal today is not just to help you to migrate to WorkManager, but really to embrace WorkManager. And to do this, I need a plan. So the idea is that I want to start explaining what is WorkManager and where does it fit in the Android ecosystem. And then from there, we're going to look at some use cases and from some lesson learned in these first few months using WorkManager. And then, because you probably know use case is equal to every other, so we will take a look at how to customize WorkManager. Last but not least important, we are going to look into how to test WorkManager. So WorkManager is part of Jetpack. And first of all, what is Jetpack? And we can look at the goals of Jetpack. And the goals are really to accelerate the development, eliminate boilerplate, and build a high-quality application. It's really because the Android ecosystem started with the APIs coming from Google for Android, and everybody was using the APIs as they wanted. But there was always a request to have some opinion coming from Google, some opinion on how to build good application. And Jetpack is really the answer to this question. So how to build good application, eliminating boilerplate, and so on. And Jetpack is composed by four main pillars: foundation, architecture, behavior, and UI, and WorkManager is part of the architecture components. You can see it here. And really, you don't need to use all of Jetpack. You can pick and choose what is best for your application. In some cases, like WorkManager, for example, WorkManager itself uses another architecture component of Jetpack, because inside WorkManager, we are using Room for handling the database storage. So what is WorkManager? WorkManager, it's a library to handle background job, but not all the background jobs. So it's really not a get out of jail free card that using WorkManager, you can put everything on the background, you can get access location or do whatever you want. No, it's simply respecting the rules of Android. It's a nice library that allows you to build a background deferrable job, having some constraints on the job. So there are some jobs, for example, where you are uploading data to a server, and you want to set the constraints that you need to have network connectivity. Or, for example, if you need to do something that is heavy computation, you want to have the device charging, so you are not killing the battery for the user. And the other things that is important of WorkManager is that the work needs to be guaranteed to complete. So it's something important that you want to have the guarantee that is going to complete. So for example, if you are doing something and it's not important that the job is completed if the user exits from the application, well, it's probably not the best option to use WorkManager. Just to make this more clear, let's see that I want to run a task, and the first question I need to answer is has to finish. It's important that this job finish. Because if it's not important and I need to run some background task, but when I exit from the application, the job is gone, I can use a treat poll or a coroutines. The other option is this deferrable? Is this something that needs to start immediately? Because if it needs to start immediately, probably it's better to use a foreground service. I can close my application, but the foreground service is still there and it's completing the job, and the user is happy. But if this is deferrable, I can use WorkManager. Deferrable means that even if I'm closing the application, even if I'm restarting the device, WorkManager will keep executing, will keep trying completing your job. Imagine that you are launching a backup, but there is no connectivity. Then you restart the device for whatever reason. You wake up the device after 1 day. There is now connectivity. WorkManager will start to do the backup at that moment. So because, as I said, it's using a database. It's using Room for storing all the work requests. So what are the benefits of using WorkManager? So you can have a one-off or periodic task, and the good thing is that you can have a chaining of these jobs. So you can have, for example, like in this case, 3 workers that are filtering an image and sending data to a compressed job and then uploading the job. And you can have data going from one worker to the other, and you can set constraints to these workers. So you can have a battery not low for the computation-intensive filtering. You can check the storage for the compression, and you can check that there is network when you want to do the upload. And this is done handling the compatibility on the newer version of Android, being a good citizen for the battery life of the device. Guaranteeing the execution, as I was saying, that even if you restart the device, you get the guarantee that the work is going to be completed. And you can then query the status of your worker and update the UI with the status of your work. And the status in this case is really just about if it's running, executing, succeeding, and so on. How the scheduler inside WorkManager, because I just say that it's covering different versions of Android, and depending on the API level, it's using or the job scheduler API or alarm manager and broadcast receivers to achieve the same goals. So it's something, nothing magic inside WorkManager. It's something that is an abstraction on top of existing API. So you can write yourself something similar to WorkManager using this API, but the question is really why are you going to write something when you have the library available? In this case, there are small details like the fact that it's using job scheduler only from API level 23. Job scheduler has been introduced in API level 21. But we know that there are some difficulties using on the first release of the job scheduler API. There are some issues. So we are using the job scheduler only starting from API level 23. And having the engineers working on WorkManager on the same corridor of the engineers working on job scheduler, it's helping the communication and helping solving these kind of issues. So to do work using WorkManager, we use worker classes. And there are not just a single worker class. There are multiple worker classes available. The main class is listable worker. This is the base class, but it's not an abstract class. So you can use directly a listenable worker. And then you have a worker that is the simplest to use class for using WorkManager. Rx worker, that is probably the best solution if you already are using Rx Java inside your application. And coroutine worker, that is available if you are using Kotlin. And it's probably the best solution if you are using Kotlin. So to give you an idea how you use in a simple worker class, how you can have your job running, we see here that I'm just doing something, and then I have this do work method that is returning a listenable worker result. It's not a Kotlin result. And I can return a success, a failure, and I can return some data inside the success or the failure. What is important about the worker class, that is the simplest to use, is that what is running inside the do work needs to be synchronous. So this is already running on a background task and on a background executor. So by default, we are running on a background executor, and you can customize this, and we are going to see this later. But the basic idea is that this needs to be run synchronously. For example, if you want to run something that is a coroutine from inside a do work in a worker, you need to run it with a run blocking. It needs to be finished the execution when you return from this method. If you need to run something asynchronously, an option is to use the listenable worker as a base class. In this case, start work, it's running on the main UI thread, and really you just decide how to run your worker, on which background executor or whatever you want. You have the full capabilities here. The basic idea is that you are returning, in this case, a listable future. So you are returning this function, and when the work will complete, the listable future will get a callback about this result. To give you an idea, this is how the worker class is implemented. So how using the list worker, this is the implementation of the worker class, calling the do work method, and on the background executor. Another option is to use a coroutine worker. In this case, do work is just a suspension function, and this is run asynchronously on the default dispatcher by default. And you can see this again from the implementation itself of the coroutine worker. You see that the start work in this case is just doing a coroutine scope and launching the do work suspended function. In this case, the coroutine scope can be redefined. It's an open, coroutine context is open, so you can customize on which context, on which scope you want to run your suspended function. In this case, coroutine context is probably not the best name of this variable. It's probably going to change in the future, but this is, at this moment, the API. If you are using RX Java, probably RX Worker is a nice option for you. In this case, your work is inside the create work function, and it's really just about using the observable and everything that is available inside RX Java. So which one to use is really about the use case you have and the code base that you have at this moment. If you are using Kotlin, probably the best option is to use a coroutine worker. If you don't need to run anything asynchronously, it's very simple. Worker is a nice choice, very simple to use. And for more complex use case, probably listable worker is capable to be customized for all the use cases. The dependencies to use WorkManager, depending if you want to use the coroutine worker or not, you can use a different runtime, the KTX version of the runtime or the Java version that provides the listenable worker and worker. If you want to use RX Java, so RX worker, there is an additional dependency for the RX Java 2 classes. And there is a test helper with different dependencies that you can use for your testing. Regarding KTX, is not just about the runtime with KTX, just about the coroutine worker. There are a few other syntactic sugar inside the library that you can use. Probably the most useful is the work data offer that allow you to, instead of building the data using that you want to pass into worker and out of worker using a data builder, you can use the work data off and build a map in this way that is cleaner and simpler. To get the status, so you have your worker running, how you get the status of your worker is through a work info. In this case, imagine that to have a complex use case where you have a unique worker that is running this cleanup worker class, and you have some constraints, another worker that continue on this, and then you enqueue all this worker continuation for WorkManager. So WorkManager is going to execute this as soon as possible. So we want to know what is happening to our worker, and we have 3 different ways to do this. One is to get the unique ID of the work request that we are interested. In this case, we get or the get work info by ID, and we get the result, what is the current result of this, the current status, or we can get an observable using live data with get work info by ID, live data. The other option is to get, given a tag, get all the matching work requests, because we can assign a string, a tag to every work request, and this can be reused for multiple work requests. So we get a list of all the work info with a live data observable. The last option is to get for unique worker. Unique worker is defined by a unique string, so we can request the work info for based on this unique worker string. These are the status of the workers inside WorkManager. So you start from the blocker status, that is when you create the job, if there is a chain of worker and a worker depends on other workers. If the other worker have not yet finished, the work in this case is blocked. Then when the worker is ready to run, but you don't need if there is an initial delay, for example, or an interval for a periodic worker and is not yet elapsed, or there are some constraints that are not yet satisfied, you can have this in the enqueued status. Then it's running, and you can have a success, a retry, failure, and or have a cancellation of the work. So these are the complete status of for the workers. How you get this information? Usually you want to have in your view model where you create the work request, in this case assigning a tag, and then you can request this live data with the same tag. In this case, I'm getting a list for all the workers that I have assigned this tag for all the work requests. And in my view, then, I can, for example, update the user interface. Is finished is a companion function that is checking if the worker is in one of the final status, so success, cancelled, or failed. And I can update the UI like in this case. All this code is coming from the code lab that we have available. So if you want to know more, there is all the description, the sample code, and so on inside the code lab. We saw that you can cancel the work or you can get your work cancelled. So, and it's important to handle this correctly. This is probably one of the most common cases where you can get in trouble with WorkManager. And it's really about being able to cancel your work, for example. In this case, you can cancel the work by using the work request ID, or you can use the tag as usual. So you can cancel all the work assigned that is using the same tag. And inside your worker, you have two things that you can do. There is an additional callback. So every worker, the basic worker, you do the work in the do work, and you can then check if your worker is stopped by overriding the onStop callback. And the other thing is that there is this function is stopped that is available to check if your worker has been stopped. So imagine that you are doing a loop or something, you can check if the worker has been stopped. What are the possibilities to have your worker stopped? Well, you can cancel it for whatever reason because of the user decide to cancel some activities. Or for example, if you are using a unique work request, you can update the work request with the replace with a replace, and so the current work is cancelled, is stopped, and the new work is then run in its place. Or the other option is that, for example, the constraints are not anymore respected. So you are setting that you want to be on charge, and your work is running. When the user disconnect the device from the charger, your work is going to be stopped. And same for another use case can be the 10 minutes limit. So your worker cannot run for more than 10 minutes. So after 10 minutes, your work is going to be stopped by the operating system and retried later. One thing that is important, when your work is going to be stopped, whatever result status you are returning is not used by WorkManager. Your work, if it has been stopped by the operating system, will be retried. If it has been stopped by you, the result is not important, and whatever it was, it's going to be thrown away. We saw most of what we saw work for one-time worker and periodic worker. There are a few differences for periodic worker that I want to talk about now. One is that you can set an initial delay for your worker when it's a one-time worker, but you cannot set an initial delay for periodic worker. The other thing is that for the unique work, you can keep and replace like the one-time worker, but you cannot append. So you cannot create a chain of periodic workers. And the third thing is that there is no succeed status for the periodic work, because once a worker is succeeded, is then enqueued again for the next execution. So it's really just because retry or success is equal in this case, you're just going back to be enqueued. One thing about the initial delay. So there is no initial delay API in the builder. What you can do is that you can use a flex interval. Flex interval is an additional period of time that is defined inside the interval period of repetition. This can be useful if the initial delay is less than the repetition interval. In this case, you have this worker is going to be executed every half an hour, and you have a flex interval of 50 minutes. Means that the execution cannot happen in the first 50 minutes of the interval. And by the way, this time, 30 minutes, is the minimum, because WorkManager cannot guarantee the exact execution of your worker. It's because maybe the device is in DOS mode, or for example, as a constraint to require the device to be in charging. So it's just the minimum requirement. Then needs to be all the requirement satisfied to be able for WorkManager to run your workers. Another option, if the initial delay is bigger than the interval, for example, if I want to have 6 hours of initial delay for a periodic worker that is executed every hour, what I can do is that I can create an additional one-time worker with an initial delay, in this case of 6 hours, and then inside my do work, I can enqueue the periodic worker. So I know that after 6 hours, this is going to be enqueued and executed as soon as possible. Another thing is that because the execution of the job is not precise, it's difficult to do a daily job. If you want to have a job that is more or less executed every 24 hours at 6 a.m. in the morning, you cannot use a periodic worker, because maybe that tomorrow morning is going to be executed at 6 a.m., the day after at 6:10, the day after 6:20, and it's going to delayed, and maybe after a month, instead of having the worker running at 6 a.m. in the morning, is going to be run at 6 p.m. in the afternoon. So what you can do is that you can use a one-time worker and reschedule the worker every time at the end of execution for the next execution, depending on what time is it at this moment. Another thing that it's important to remember is that WorkManager is keeping the worker inside the database. So if you are doing something like enqueuing your worker every time that you are running your application, so inside the application on Create, it's important to use a unique, the enqueue unique work, so to have a unique work request. In this case, I'm using the keep policy, means that if there is already a worker that is running in the queue with this unique name, my unique work name, this work request is not going to be appended to the list of worker to run. Because if you don't do this, if you use a normal work request, you are going to add every time that you run your onCreate method in the application, you are going to add a new work request. This means that, for example, if you have a constraint of charging and the device has not been charged for the last 3 times that you enqueued this job, next time that you are starting to put the device on charging, all the 3 requests are going to be executed, and you are going to wonder why it's executing multiple times. The same for periodic worker. In this case, it's a different method name for periodic workers, and it's a different work policy, periodic work policy. Still keep or replace, but it's a different class name. Okay, so far everything that we saw is the standard configuration of WorkManager. What if you need something else? What if you want to provide your custom executor? Or what if you want to set a different login level for WorkManager? Or what if you want to have your worker factory? Having a worker factory is important if you need to change the constructor parameter of the worker, because you are not invoking the worker's constructor. It's WorkManager calling through the work factory your workers. So if you want to use something like Dagger, for example, and add a parameter to the constructor, you need to have your custom worker factory. In this case, you need to disable the default initialization inside the Android manifest with a node remove. And then in the entry point of your application, I'm putting here the application on create, but if you have a broadcast receiver and your application can start from there and work with WorkManager and call WorkManager from there, you need to initialize WorkManager even from that path. So in this case, you can create a new configuration where you can set a minimum login level, a worker factory, and then you initialize and you get the instance of the singleton instance of Worker Manager. We changed a bit the API during the alpha period. If you try to do an initialize and WorkManager is already initialized, WorkManager is going to crash. Simply to help to understand that you probably forgot to remove the WorkManager initialization inside the Android manifest, because we were seeing issues where people were thinking to have initialized WorkManager, but in reality, it was the custom initialization that was starting before the default initialization starting before the custom init. And in the worker factory, you have this create worker. You have the worker class name that you can use to decide which worker to create. You can have additional parameters here. In this case, I'm just creating one worker, but it's really about, okay, let's see the package name of the class that I'm creating at this moment and what I want to do. For testing WorkManager, at the end, not because it's not important, but because I tried to do this the other way around, doing the test-driven conferences. It doesn't work very well, so the testing is at the end. We have this test init helper, where you can get a custom executor that is a synchronous executor. I'm showing it here in the custom configuration. In reality, even if you don't have a custom configuration, the initialized test WorkManager, it's using a synchronous executor. And the reason is simply because in this way, you run your worker, the worker runs synchronously, you can test the result. There are some helper methods even for periodic worker to be sure that the time is elapsed. So if you have a periodic worker that is executed every 30 minutes, you don't need to wait 30 minutes, or if you have an initial delay of 6 hours, you can test this directly and without having to wait. And inside your test, simply about, in this case, I have some input data that I'm creating a work request with the input data and queuing and getting the result immediately because it's synchronous. And then from getting the work info, and from the work info getting the output data. Then I can check if the output is what I was expecting. So in this case, it's creating a file, and I'm just checking if the state is successful. So migrating to WorkManager, because WorkManager is not the first library to run background jobs. We are trying to make this the last one that you need to migrate to. So there are alternatives to WorkManager. One is the job scheduler, and the other one is the alarm manager plus broadcast receiver. But these two solutions, in one case, the job scheduler, it's only available from API level 21 up. And we have seen that even WorkManager doesn't start to use this library from API level 23. And the other option is the alarm manager, but using alarm manager, it's we get always more and more constraints on alarm manager on newer version of the operating system. So you should use both depending on which API you are running your application on. That is what WorkManager is doing. So these are two alternatives. Another alternative is the Firebase JobDispatcher. And this is now officially deprecated on the GitHub account for the library. You get the news that it is deprecated. They are not going to support new feature coming after Android Q. And they suggested path moving forward, they suggest to migrate to WorkManager. Another option that is used a lot in the Android ecosystem is the Evernote Android Job library. And if you go on GitHub on the GitHub repository for Android Job, you see that the same note that the library is now starting to be deprecated, and they suggest to migrate to WorkManager. So it's really not because WorkManager is better than every other library. We think that we are doing the job to make it better than the other, but it's really a difficult job to do, running background work in a reliable way, like WorkManager is doing. So as soon as every other library see that there is something like WorkManager available, they are starting to say, okay, we can stop it, develop this, and start to use WorkManager. So especially for Firebase JobDispatcher that is very used, there is a documentation page just for this. The basic idea is that instead of the simple job service, you can use a worker. Instead of job service, you can use a listable worker. And you see that in this case, you have the start work that, and depending on what you want to do, if you need to run on a background thread or not. And as usual, remember to do some cleanup if your on-stop is called. The other difference that I think is important to say is that the data, the input data, the output data for the worker is a data class that has a maximum size of around 10K. And you can put inside data just the basic data type and some array of this basic data type, but it's not a bundle like in the Firebase JobDispatcher case, where you can throw everything that is parsable or serializable. In this case, you may need to rework your logic to move some of the data that you need to bring into the worker to rely them on some database or whatever, because you cannot use the data for a larger amount of data. So for example, the code lab we have, we are using images, but we are just sending to the worker using the data object, the URI of the file that we are using under the hood. So the conclusion, it's a few things before we take off. There are new branches of the two branches of the WorkManager. Version 2.0 is the Android X branch, and is where all the new development is done. The other branch is the 1.0 that is not much older, but is at this moment 1.0.0 and 2.0.0 are exactly the same functionality, but all the new development will be done on the 2.0, and the fixes are going to be backported to the 1.0. So if you are not using Android X at this moment, you can use the version 1.0. If you are already using Android X, 2.0 is the way to go. And if you are not planning to migrate to Android X, I'm just wondering why. So it's probably a good idea to migrate to Android X. If you use Kotlin, probably coroutine worker are the best option for you. There are some questions regarding how to test coroutine worker, because they are not running on the same default executor that is used by all the other worker, by the worker. And in this case, when you do the testing, you can use the synchronous executor, but in reality, your coroutine worker is running on a dispatcher. So you need to override the coroutine context used by your coroutine worker to be able to have it running on something synchronous in that case. Don't forget to handle cancellation and stopping. This is really important. This is probably one of the most common use cases of problems with WorkManager because, well, simply because the worker, most of the time it works. But when it doesn't work, it's probably because it's been canceled by the operating system, and the result is not used, and you don't know exactly what is happening at the moment. If you need to do something once, you have the unique work request, and please use the unique work request because we have seen cases where people was complaining that WorkManager was executing multiple times the same job, and the reason was simply because they were enqueuing multiple times the same job. And work is persistent in the database. This is a clear decision to be able to provide something that resists to the closing the application and resists to restarting the device, but it's a database. So if sometimes we see problems of people complaining that there is an out of memory when using WorkManager because there is no more disk space, where there is not much that we can do in this case. So there are some parameters that you can set in the work request to limit for how long is going to be persisted after the execution, and you can work on this parameter if you have problems with the amount of data that is saved in the database. Some resources at the end. So there is a lot of documentation in line. When we went online with the version 1.0 stable, we reviewed all the documentation, and I think they are really great. If there are problems in the documentation, please let me know. There is a code lab. This is the Kotlin version. The same code lab is available in Java. On the repository of the Kotlin version, there are all the testing that I showed today. There are some testing done there to test the worker class in the code lab. And there are release notes. There is a nice talk done last year at ADS by the engineers working on WorkManager. There is a guide on background processing, because as I told at the beginning, WorkManager is not a silver bullet for all the different background processing type that we have on Android. So this guide is really good, explaining what are the best solutions for the different use case. And the last part is that WorkManager, like all the other Jetpack components, it's open source. It's inside the IOSP. I showed today some of the snippets of code coming from the WorkManager samples, WorkManager's source code. So if you have any question, probably, as always, with a open source project, it's nice to look at the source code to understand how something is done. And that's all. So thank you very much.